Hello and welcome back. This video tutorial is going to help with the homework capacitors in series and parallel. Remember to pause and rewind the video as needed and try to work your problems along with me. If you're having trouble and you're still not getting it correct, put question marks next to what you're not understanding and come and see me about it. Let's begin. First, open up the PDF that says capacitors in series and parallel. And when you do, you're going to find 4 questions. The first one is called energy stored on capacitors in series. Question 2, capacitors in a parallel circuit. Question 3, series of capacitors in parallel. And question 4, parallel of capacitors in series. Let's begin. First, let's go ahead and open up the program for question number 1, energy stored on capacitors. And it says this circuit is built with 2 capacitors hooked in series with each other and then connected to a battery. Determine the voltage across each capacitor and then the energy stored on the capacitor. Make sure you put your final answer for energy stored in joules. Okay, put your name in there. Let's get started. Now, you'll be given capacitor 1 and capacitor 2 in series. My capacitor 1 is 71 microfarads. My capacitor 2 is 25 microfarads. And my voltage across the power supply is 12 volts. Okay, so what I'm going to do is I'm going to write down that information to get started. Okay, so my first 71 and 25. So 71 and 25. Okay, now what I'm going to do, I'm going to just kind of remind you briefly, how do we deal with capacitors in series and in parallel? So in series, we do the inverse of the sum. So we add up the inverses, capacitor 1 inverse plus capacitor 2 inverse, and then we inverse that sum, right? And then plus, of course, however many there are. In parallel, that one's even easier. It's like resistance in series. You just simply add them. Capacitor 1 plus capacitor 2 plus however many you have. Okay. So what I'm going to do is I'm going to find the equivalent capacitance. That's what I'm going to do. So we're going to go 1 over the equivalent capacitance would be 1 over 71 plus 1 over 25. So I'll go 71 inverse plus 25 inverse, and then I'm going to inverse my sum. Okay, you do the same. '71 inverse plus 25 inverse is 0.054, and then if I inverse that, I get about 18.48, so about 18.5. Okay, so that's going to be 18 microfarads. So now my steps kind of go like this. Okay, here's what I want to do. I want to, step 1, find the equivalent capacitance. Combine all your capacitors. Okay. Step 2, find total charge. Okay, total charge on a capacitor. Now we do that by going charge equals capacitance times your potential difference. Okay, times your voltage. Now I'll just shorthand write it as C times V. Okay, and then step 3, we work back to find charge and voltage for each capacitor. That's what we're going to do for every one of these 4 problems. Okay, so what I'm going to do now, I'm going to find total charge. So let's do that one together. Go ahead and find yours. I'll find mine. My total charge is going to be C total, or C equivalent, times V total. Okay, and I'm going to leave it in microfarads right now. I'll show you why. When we do our energy calculation, we do need to put microfarads as times 10 to the negative 6 for an energy calculation. But for just a quick charge calculation, microfarads will basically give you microcoulombs of charge. So it's an easy transition, okay, if we're multiplying just by voltage. My voltage, I didn't write it down, was 12 volts. Okay, so I'll multiply that by 12. So 18 and a half times 12. So I'm looking at 222 microcoulombs of charge. Okay. Now here's what I know. Here is what I know. And was true for resistors, but it's true for capacitors too. Okay. My series parallel chart, current and charge, current and charge are both the same in series, summed in parallel. Voltage, summed in series, same in parallel. So charge, right, has the same rules, the same analytical rules as current does. And that should make sense to you because current is the flow rate of charge. Okay. All right. So what do I know? I know if the total charge is 222, that means there's 222 microcoulombs of charge on that and 222 microcoulombs of charge on that. Okay. So, oh, I suppose I should move that down. So this calculation was supposed to be down here. All right, let me rewrite that. Okay, there we go. Sorry, gotta fix this. Okay, so 1 over the equivalent capacitance, 1 over C1 plus 1 over C2 plus dot, dot, dot. Okay, sorry, I ended up erasing step 3 by accident. So just to quickly summarize, step 3 was about working back, work back to find charge and voltage on each capacitor. Okay. All right. Now, so I know the charge is the same, so I wrote that. But now what I could do is I can calculate the voltage on each one. Because if I know charge is capacitance times voltage, if I divide by C both sides, I know voltage is going to be the charge divided by the capacitance. Okay. So now notice you're basically you're dividing micro by micro, so the 10 to the negative 6 factor of both is going to cancel. So that's why we left it that way. It'll just make it really easy calculation for voltage. So for voltage 1, okay, we're going charge over capacitance. So I'm going to go 222 divided by 71, and that gives me about 3.13 volts across capacitor 1. And then I'm going to go 222 divided by 25, and that gives me 8.88 volts across C2. Now, if I were to add those two, right, there's no surprise, I get 12 volts. And that's because voltage in series, right, is summed. Okay, so now, oh, okay, so this belongs down here. Okay. And then calculate the voltage across each one. So I did that. So the voltage across 1 is going to be Q1 over C1. The voltage across 2 is going to be Q2 over C2. Okay. So Q1 again was it was 200, Q1 and Q2 are the same. So it's 222 microcoulombs over 71 microfarads. The micro cancels, right? And that's how I got 3.13 volts. And then for this one, it was 222 microcoulombs over 25 microfarads. And again, the 10 to the negative 6 part, the micro, right, cancels in both, which is nice. And that one gave me, I think, 8.88, if I remember right. Volts right there. Okay. Now let's go ahead and put our answers into the program, see how we did. Okay, and did I find, oh, the voltage and energy across each capacitor? I forgot to do that. So to find energy, okay, the energy calculation, so if charge is equal to capacitance times voltage, well, energy on a capacitor, you could do it one of two ways. So potential energy, UC is the potential energy on a capacitor. The sub C stands for capacitor. And I can go 1/2 CV squared, so 1/2 times capacitance times voltage squared. Or I can go 1/2 times QV. Either way works, okay? I tend to like to use this way more, honestly, because I will find the voltage on each capacitor and I will already know the capacitance of each capacitor. So I tend to like that one a lot better. That's just my personal preference, but this one does work too, okay? So I'm going to find the energy on both. So U1 would be 1/2, basically C1V1 squared, and just plug into it. Okay, C1. Now here's where you got to put them in. The capacitance C1 was 71 microfarads, but this is where I got to go 71 times 10 to the negative 6, right? Times the voltage, which across that one was 3.13 volts squared. Okay, so that's what I'm looking for. I'm gonna get a really small energy. So 3.13, okay, square it times 71 times 10 to the negative 6, right? And then I'm going to take half of that, and I get about 3.48 times 10 to the negative 4 joules is my energy across capacitor 1. And my energy across capacitor 2, 1/2 C2V2 squared, and we'll go 1/2 times 25 times 10 to the negative 6 times 8.88 volts squared. So 8.88, square it, times 25 times 10 to the negative 6 power, and then take half of that, and we get about 9.86 times 10 to the negative 4 joules. Okay, so let's go ahead in the program, enter in our data, and let's just see how we did. Hopefully we did well. So I got to enter in voltage 1, voltage 2. So my voltage 1, if you remember, was about 3.13, and my voltage 2 was about 8.88. Okay, enter in your values. My energy 1 was 3.48. Now to enter in scientific notation, you'll go, I would go 3.48. Then I'll go back to the letter here, E, that's my times 10, to the negative, I got to find the dash, okay, negative 4, okay, and I'm going to do the same thing, okay, for the other one, it was 9.86, so we're going to go 9.86 E negative 4. All right, and there we go. Okay, we did good. Hopefully you did good as well. All right, and if you got that right, hey, let's ready move on to number 2. Number 2, capacitors in a parallel circuit. Go ahead and enter your name. Let's begin. Now, first thing we're going to do is we're going to write down our numbers. C1 is the top, C2 is the middle, C3 is the bottom. So 90, 91, 31. 90, 91, 31. 90, 91, 31. Yes, that's right. Okay, this was C1, C2, 3. Okay, so the first thing I'm going to do is I am going to find the total capacitance, right, and the total charge. Those are the first two things I'm going to do all the time. Okay, so how do you find the total capacitance? Well, in parallel, you find the total capacitance by adding it up. So it'd be C1 plus C2 plus C3. So it's going to be 90, in my case anyway, 90 plus 91 plus 31. So go ahead and add up yours. And I get 212 microfarads is my total capacitance, my equivalent capacitance. Okay, my total charge stored, Q total, C times V. So I'm going to go my C is going to be 212 microfarads times, I forgot to jot down the voltage on the battery, is 4.5 volts. There we go. Okay, times 4.5 volts. Okay, so we're going to go 212 times 4.5. And we are looking at 954 microcoulombs. Okay. Now here's what I know. Okay. It says calculate the voltage and energy across each one. Well, the voltage is the same. See, V total is the same as V1, is the same as V2, is the same as V3. They're all 4.5 volts because they're in parallel. So that's easy. So what I'm going to do is I'm going to go to my circuit and I'm literally going to write next to each one of these, I'm going to write 4.5 volts, 4.5 volts, and 4.5 volts. And I'm writing it next to the capacitance. Why? Because Q is equal to capacitance times voltage. So if I write it next to it, it just gives me that visual reminder that I need to multiply these two to get the charge. So what I'm going to do is I'm going to find the charge on each one. Okay. So I'm going to go 90 times 4.5, right? And I get 405 microcoulombs. Okay, and then on the second one, I'm going to go 91 times 4.5, and that one I get 409.5 microcoulombs. And then the third one, I'm going to go 31 times 4.5. And for me, I'm getting about 139.5 microcoulombs. Okay, so that's what we do. We're going to find the charge on each one. Okay, so we got the voltage and the energy. Now, how do we find the energy? Well, if we have the capacitance on each one. So the energy U1 is just going to be 1/2 C1 V1 squared. Just plug into it. Okay, so 1/2 times C1 was 90 times 10 to the negative 6 times V1, which is 4.5 squared. Okay, U2, 1/2 times C2 times V2 squared. So 1/2 times 91 times 10 to the negative 6 times 4.5 is the voltage across that squared. And then U3 is going to be 1/2 times C3 V3 squared. Okay, so we're going to go 1/2. And then for that one, it was 31 microfarads. So 31 times 10 to the negative 6 times 4.5 volts squared. Okay, so let's figure out the energy for each one of these. Okay, we're going to go voltage first. So 4.5 squared times 90 e to the negative 6. Take half. Okay, and we're looking at 9.11 times 10 to the negative 4 joules. Okay, and then the next one, we'll go 4.5, square it, times 91 times 10 to the negative 6 power. Take half of that. And we are at 9.21 times 10 to the negative 4 joules. And then the last one, we're going 4.5 squared times 31 times 10 to the negative 6, and then we'll take half of that. So I'm looking at 3.14 times 10 to the negative 4 joules. Okay, got those. Let's enter into the program and see how we did. So my total capacitance was 212. Okay, my total charge was 954. Go ahead and enter in your values. And the energy on C3, well, see, here's the thing. If you find literally the charge, the voltage, and the energy on every single capacitor, this is an easy answer because you already have it. We already did the work. So I look up U3, and that was 3.14 times 10 to the negative 4. Okay, so we're gonna go 3.14 e negative 4. All right, and there we go. Okay, hopefully you were able to get capacitors in a parallel circuit correct as well. Okay, if not, put question marks down to what you're working on and come see me about it. If you got it right, well, then let's go ahead and move on to question number 3. Series of capacitors in parallel. Begin by putting your name. And let's put these values onto our circuit. 28, 88, and 18. So 28, oops. 28, 88, and 18. And we were given a voltage of 6 across the battery. Okay, got that. So now what I'm going to do is I'm going to redraw this circuit. Okay, what I'm going to do is I'm going to combine these two. These two are in series, so I'm going to combine them. And I do that by going 88 inverse plus 18 inverse, right? And then inverse my sum. So my circuit will now look like this. Okay, and I'll have 28 microfarads there. And if I go 88 inverse plus 18 inverse, and then inverse that sum, I'm looking at about 14.9. So 14.9 microfarads, okay, across the bottom. And what's nice about this is the equivalent capacitance is easy. It's just the sum. At this point, I can just add them, right? That's pretty easy. So the equivalent capacitance is going to be 14.9 plus the 28 on top. Okay, and I'm looking at 42.9 microfarads. Okay, got to calculate total charge. So we're going to go Q equals CV. So the capacitance, the total capacitance was 42.9 microfarads times, I forgot the voltage, 6 volts. 9 times 6, we're looking at about 257.7 microcoulombs. Okay, got that part. Now we got to calculate the voltage across and the energy stored in each capacitor. Okay, so here's where we begin. Your last circuit was a parallel circuit, and you know voltage is the same. So you know that this is going to be 6 volts. You know this is going to be, I'll read through this in red, 6 volts, and you know this is going to be 6 volts. So you know that to find the charge for each one, you just simply have to multiply. So I'm going to go 28 microfarads times 6, and then 14.9 microfarads times 6. So I'm going to find the charge on each one. So 28 times 6 is 168 microfarads, which I'm going to copy down over here, 168 microfarads right here. And it was 6 volts. Okay. And then off the bottom, we know that that one, we're going to go 14.9 times 6, and we're looking at 89.4 microcoulombs. Okay, now one thing we know coming back to this circuit here is we know that those two, 88 and 18, C2 and C3, they're in series. So they should have the same charge. So I'm going to take that charge, I'm going to put it to both. Okay, so it's going to be 89.4 microcoulombs and 89.4 microcoulombs. Okay, now if I remember right, if charge is equal to capacitance times voltage, that means voltage is equal to the charge divided by capacitance. So if I take my charge that's written in blue and I divide it by my capacitance, I get my voltage across each capacitor, 1.02 volts for C2 and 89.4 divided by 18, about 4.97 volts across that. The two of those, these two should add up to 6, right? Because voltage in series is summed. Right, so I've got everything. I've got capacitance, voltage, and charge on each one. So now that I got that, and I wrote this one wrong. I'm sorry. That should be micro coulombs, not farads. Okay. So now that I got that, I'm going to go ahead and just kind of see what else we need here. We know the voltage across the energy stored in each capacitor. So we just have to show our work for one. We don't have to show work for all, but let's say we did C1, for instance. Okay, so C1 is going to be uh, so the value for C1 was 28 microfarads, right? And so if I want to find voltage across that, V1, it's going to be Q1 over C1. So 168 microcoulombs divided by 28 microfarads, and 168 divided by 28, of course, gives me 6. And I actually started with 6 volts and I figured out the charge from that. Okay. Energy. Okay. Find the energy stored. Well, I'm gonna choose the one that I'm looking for. I'm looking for which one here? Just gonna move this up here. I'm looking for energy in C2. Okay, C2. So I'm gonna go to capacitor 2. Okay, and so energy, so U2 is going to be 1/2 C2V2 squared. So that's going to be 1/2. Now C2, which was 88 microfarads. So we're going to go 88 times 10 to the negative 6 times the voltage across V2. If I look back at that, it was 1.02 volts. 1.02 volts, and I got to square that. Okay, so I'm going to go 1.02 squared times 88 times 10 to the negative 6. Okay, and then take half of that. And I'm looking at a pretty small value. So this is about 4.58 times 10 to the negative 5 joules. So 4.58 E negative 5. Total charge was 257.7. 257.7. And the total capacitance was 42.9. So just put in all your values. See how you did. Okay, there we go. All right, hopefully you were able to get this right as well. If so, let's jump on to our final question. If not, put question marks next to what you're doing. Try it again, okay? And come and ask for help if you're still stuck. Our final question is called parallel of capacitors in series. Go ahead and jot down your C1, C2, C3 on your okay, so like that. We're gonna go ahead and we're gonna list what they are. So my C1 is 53. So I've got 53. Okay. We have 38 and 26. So jot down your numbers too. 38 and 26, and my voltage was 3 volts. Okay. So what I'm going to do to make this circuit more simplified, what I'm going to do is I'm going to first combine those two, and in series, or in parallel, excuse me, we add them. So if I were to redraw this circuit, I would have my battery, okay, goes over one capacitor and two capacitors, and then it's back. Okay, so I already know this is 53 microfarads. Okay, and I know that the sum of those two, right, are going to be, in fact, let me just go ahead and, so calculate, okay, so calculate the capacitance of the parallel. So let me just move that. Let's select it. Let me just move this down. Yeah, let's move this work down here, make it simpler. Okay. So I know that when I see those two in the parallel branch, it would be 38 plus 26. So go ahead and add yours. 38 plus 26. I'm at 64. Oops. 64 microfarads, okay? And that was 3 volts. Now to find the equivalent capacitance, I got to go 1 over the equivalent capacitance is 1 over C1 plus 1 over C2. So 1 over the equivalent capacitance is going to be 53 inverse plus 64 inverse, and then just inverse that. So 53 inverse plus 64 inverse. Okay, inverse that, and we're at about 28.99. I'm just going to round it up to 29. So, okay, 29 ohms. Got that. Okay. And then now I need the total charge stored. So that's going to be Q equals CV. So I'm going to go 29, 29. Oh, I wrote ohms. My head is still in resistance mode. Sorry. It's going to be microfarads. So I'm going to go 29 microfarads times 3 volts. So 29 times 3 gives me 87 microcoulombs. Okay, got that. Now we're going to calculate the voltage and energy across each capacitor, and then we're going to show our work for just one. Okay, so here we go. So starting with this, I know the charge is the same. So I'm going to put that same charge, 87, across each one. So I'm going to go 87 microcoulombs, 87 microcoulombs. And I can find the voltage by dividing charge over capacitance. So 87 divided by 53. So that's how I'm going to choose just V1 to be simple. So V1 would be Q1 over C1, and that's 87 microcoulombs divided by 53 microfarads. The micropart cancels. Okay, and 87 over 53 is about 1.64. Okay, volts. Okay, but I'm going to find them on volts. Okay, so that's 1.64 volts. Okay, and the other one, 87 divided by 64, about 1.36 volts. Okay, and the sum of those should add up to 3 volts. So I've got everything I need. I need to now work back. I know voltage is the same in parallel. So I know that C3 and C2 are in parallel, so they both should have 1.36 volts across each one. Okay, and if I multiply those two, I will get the charge. So let's go 1.36 times 26. That would be 35.4 microcoulombs. Okay, and then if I go 1.36 times 38, that's 51.7 microcoulombs. Okay, so I've got everything now, and here I had 87 microcoulombs and 1.84 volts. Okay, so I think I've got everything. Now let's go ahead and enter our stuff into the program, and let's see how we did. Okay, so my first one is 29 and 87. Those were my first values. 29 is my total capacitance, 29 microfarads. Okay, 87. Okay, and then my energy stored in C3. So let's look at C3. C3 was the upper one, so I need to go 1/2 CV squared. Okay, so I'm going to go U3 is 1/2 C3 V3 squared. So C3, when I look at it, is 38 microfarads. So let's go 38 times 10 to the negative 6, and then times the voltage across that, which was 1.36, and I need to square that. Okay, so let's go 1.36, let's square it, times 38 times 10 to the negative 6, and then divided by 2, and we're looking at a very small energy of 3.51 times 10 to the negative 5 joules. Go ahead and put in your values. I'll put in mine. 3.51 E negative 5. All right, there we go. Okay, hopefully you were able to get question number 4 correct as well. If you had any trouble with any of these questions, please put question marks, specific question marks next to where you're having trouble. Come and see me and we'll get it worked out for you. I hope you found this tutorial to be helpful. Thank you. See you next time.